Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we're going to look at K Nearest Neighbour, or KNN for short. This is a simple machine learning approach to performing classification, and it's based on having an existing dataset where the cases are known and then applying that information to our data that we want to be classified. So for example, we may draw out a little chart here where we've got a couple of variables, an x and a y variable, and we may have a number of data points on that chart. So for example, we may have data point here, data point here, data point here, for example, and we may have some other data points, for example, like that. So what we may be looking at, in fact, for example, here is the recent spend on the x-axis, and on the y-axis we may have income, or it could be total spend, or whatever you want it to be. So we've got a couple of variables, we plot them out, and what we can see are some are red and some are yellow. In fact, the yellow ones, these are male customers, and the red ones we already know, these are female customers. So what we want to do is, if we were to provide a new data point, for example, we put a data point here in white, should that customer be male or female? And so by using K Nearest Neighbour, what we say is use the training data we've already got, and based on what you see there, try to establish whether this data point should belong to the male or the female classification. And that's done, in fact, very simply. It's done by specifying a value for K, which is basically how many neighbours you want to have, and then extending out from your data point and looking at the number of neighbours. So for example, if we set a K value of 3, we'd be looking for the situation where we have 3 neighbours of the same type. In this case, we have 3 males, which are closer than 3 females to that single data point. So in this example, we would be able to predict that the value of gender for this white data point would be M for male. We set K to 3. However, we may set the K value differently. We may set it to a larger number. It's totally up to us. So in this case, for example, we may set the K value to 5 or 6. Maybe we set it to 6. So if we count out from here, do we have 1, 2, 3, 4, 5, 6 values, okay, for male. Maybe we set the K value to 7, but within this area we have 1, 2, 3, 4, 5, 6, 7, 8 values for female. So if we set the K value here to 7 or more, then in fact, or 8, then the value for gender would be female. If we set it to 6 or less, then the value would be male, because we're seeing that here. So that's an example of exactly how it works. It's very simple, very elegant, and of course we're able to do this on a very large volume of training data, perhaps hundreds or hundreds of thousands of different data points, to maybe enable us to get very accurate results. So now let's have a look in Studio at how we actually create the code with HANA. Now the approach for KNN within HANA is very similar to what we've already seen with the PAL algorithms. Of course, first we need to reference our schema where we have our data, and we'll create our procedures. And here's some code I already made. We can see we have actually 4 tables involved with the KNN, the K Nearest Neighbour. We have a set of data. Now this data is the training data. It's where we already know the type that we want to classify. It's existing data, and this is what we use to train the model. Now in my case, similar to what we just saw, we're going to have actually gender for customers, and we've got their lifetime spend and their recent or new spend. So we can see we've got the ID of the customer, we've got the customer's gender, which is known, 1 or 0 for male and female, we've got the lifetime spend and the new spend. And so this we can pull out of our existing transactional data. We then have something called the classification table. This is where we provide the information, basically the coordinates of the lifetime spend and the new spend, for which we want the gender to be predicted. So this is basically our definition of what we want to be done in terms of predictions. We can have any number of different customer IDs in there. Then we have the parameter table, as always, same structure that you're familiar with. and we have a predict table, and this is the table that the algorithm will actually update. In fact, we will insert rows. For every ID we put into the class table, we will get a row with the same ID in the prediction table with a gender value, whether that's 1, 0, or whatever the values happen to be possible in the training data we provided. So we use the traditional approach. We go to the signature file, we reference these 4 tables, whether they're in or output parameters, and we call the wrapper generator to actually generate us a procedure we can then use. And in this case, for K nearest neighbor, we just simply need to specify that this is a KNN algorithm. That's the code we need. More information on that, as always, in the doc. So why don't we go ahead and just run this code and generate our procedure. So that ran very quickly. The next thing is actually to provide your data and to actually create the tables. Now we've made that definition. So we saw already in some of the regression examples, we've got some transactional data. We've got information, in fact, on where we can identify from all of the sales transactions, taking all of history to get the lifetime spend for each customer. And we can take maybe just a particular calendar ID, so maybe the last period or the last quarter, to get the more recent spend for that customer. We can join those together. We can also take in the customer gender that we know for each customer, whether they're male or female. So we've got that information. So we can create a view, which is the easy way, rather than physically having to put that into a table. With HANA, we can just create a view. Now here we actually have over 1 million facts in our fact table, so over 1 million transactions, and we have 200,000 different customers. So this is big data. This is not just some trivial 20 or 30 rows. This is big data which we're able to work with HANA. Then we create our class table structures, the parameters of prediction, and maybe we want to create to identify or predict values for lifetime and new spend for these values in dollars or euros. We'll give an ID for each one. So we're going to actually get 2 results predicted based on that 200,000 different customers that we have information for. We've also got some parameters here. There are a number of parameters. Thread number, you know and love. It's seen all over PAL. We have something called attribute num, and this is where we specify the number of different attributes that are relevant. And here we've got 2. We've got lifetime spend and new spend, but you're not limited to 2. That's obviously very easy to show you in a chart, but if you want to have 3, 4 or more, you can have a much more complex model with a large number. So here you specify how many attribute variables you've got. In our case, it's 2. You also need to specify what your value for K should be. How many nearest neighbors do you want? How many related data points, as we saw, to your data to be predicted? And here we may choose 3, but it's totally up to you. And one of the big questions actually with this is, what's the best value and the most appropriate value of K? But of course with HANA, as we've seen with other algorithms, you may be able to loop around and actually calculate for all different values of K to try to work out maybe which one is the most appropriate for you. So you can run things very quickly with HANA. And final algorithm, in terms of tuning how the algorithm works, there are a couple of approaches that the PAL supports. Either the majority voting approach, which is where it's the most number of data points that are closest to the data point you're trying to predict, or you can have, as you set the value to 1, a distance weighted approach, where it's not simply just the number, but it's the overall distance of all of them, which one is closer, the overall distance for this or that, for male or female. So you've got a couple of approaches. You can tune the way it works. So we create that information. Let's run that code to create the tables, and let's go off with that. So that now runs very quickly. We created our view, even though it's on a very large volume of data. And now, simply for the first time, we can run our code. So we need to call a procedure. We created the name. As always, it's in _sys_AFL. And we give it the input data, which in our case is a view, the classification, the data we want to be predicted. We give it the parameters and the name for the output table to contain the predictions. And we'll just browse that table. We'll do a quick select just to save time as we run. So let's now run that code. And you see in just a few seconds, or not even a second, it ran through training data of 200,000 different customers, and was able for our 2 customers that we put into the classification data to tell us that the gender should in both of those cases be 1, which would be male, 0 being female. So it's a very quick and very easy way to actually perform predictions. Now maybe we want to tweak it a little bit. Maybe we want to change the number of nearest neighbours. So instead of 3, maybe to do a second run, we could update our number of nearest neighbours to 10. So we could just run that code, clear out our predictions table, and run the algorithm again. And this time, we see again, it's the same, gender of 1 and 1, so both male. However, it might be that we want to also change the voting type. Instead of saying the majority, just counting the number of neighbours, looking at the actual distances as well and bringing that into account. So we could update the parameters here to set the value for voting type to 1. Again, more information on that as always in the manual. Let's update that and let's run the algorithm again. And this time we see actually it's taken the same classification data, but it's decided this time it would be more appropriate to predict female, so 0 value for gender, because we've actually changed the approach we're taking and the number of nearest neighbours. So you've got lots of flexibility to tweak and to play with this and to evaluate what the best approach to be. It's very simple and it works very well with HANA, with the PAL on particularly large volumes of data. So that's the K Nearest Neighbour.